My name is Gregory Leugers. I attended Air Force Institute of Technology and I studied IT project management. Also learned quite a bit of my hackery skills there. So the OWASP project I lead is OWASP Mantra OS. It is a sandbox attack platform that is built for cloud instances such as vSphere and Overt and other systems like that. So let's dig into this. I also apologize there's going to be a lot of flashing of blue screens because I'm switching between two different VMs to show the demo of the attack. So when that happens, I apologize. So to give you just an overall what Mantra is, this is Mantra OS. Right now it's running Cert Stealer. I'll show you the demo of that in a minute. Okay, so I'm also a platform security engineer at HighTrust. It's a lovely cloud security company. Mantra is a virtualized attack platform designed around the Mantra Security Toolkit and the OWASP WTE repository. It's developed for SCAP testing and development, professional pen testing, and optimized for, as I said, vSphere, Zen Desktop, OpenStack, Overt. It's available in a ISO and the NSI standardized virtual format of OVF/OVA. Mantra is used throughout the lifecycle at HighTrust. We use it as our core of a security assessment plan, a part of our whole development lifecycle, and each feature verification has to go through Mantra's testing. And it's been used as a very automatable tool for testing because security engineers don't have all the time in the world to test every point, so it has to be automated at some level. The virtualization and security, a lot of it comes through the kernel, and we use GR security with OpenVZ to create a secure, pretty much container. And it also uses Gianetti as the virtual cluster because when you're containerized, shutting down can be quite difficult if you're not talking properly through the stack. And then we use KVM as a second layer of implementation of virtualization to ensure that the images are running cohesively and whatnot. And it also creates the ability to create a team server out of one deployment of Mantra. So if you have a team of 12, you can literally each have your own container instance running the pen test. It uses OpenVZ with LXC and Arcro's dbus hook to sandbox the actual physical desktop and uses libvirt to handle the virtualization tasks that would be required to do exactly that. So this is actually the API map of Mantra desktop. It goes through LXC, libdispatch, libvirt, libjit. These make it so it's actually intuitive to the user's demands, because if you have multiple tools up, sometimes with Backtrack it lags out. This is to avoid that type of feeling, especially when you're virtualized in a cloud instance. When you're looking at a desktop, possibly through RDP, that can be quite laggy if it's not properly done. So it includes IDS protection with Suricata, Artillery to do as a overall protection, and Honey to basically, if an attacker is attacking back Mantra, Mantra can defend itself and send them to a honeypot and they can have fun wasting hours in a honeypot. It also contains AppArmor and SE Linux. They run cohesively together to ensure that, pretty much acting as to ensuring that files aren't altered by an exterior user. The audit tools are Zap, BERT, Multi-Ego, Metasploit, Armitage, and ZenMap. They are all part of the WTE repository. We also use EtherCap and Wireshark for our PCAPs. Our scanners are Skipfish, Nikito, Gregory, and our SQL injection, SQL Brute, SQL Map. SQL Map is actually integrated with Zap, so when you're running your active scans, it actually uses SQL Map, or SQL, and Multi-Ego for Intel collection. This is the download. Now we can actually do the fun demo that I've been wanting to do. So this is actually the first demo of Search Stealer. So the whole point of Search Stealer is to show the undermining pins of when you pen a PEM certificate, the subject alternative name and the certificate key actually create almost a fake level of trust with the certificate. And if it's spoofed, it might throw a red flag, but it doesn't alter that. And in cases like this, let me open a Chromium browser to show you. So this will not be trusted because Google right now is the local loop of Mantra. And so it sees itself as 127001. But if I go to here, it says something is wrong with the certificate, but it does not understand why. And because the pinnings are so similar, Chrome does not block it, which in general sense it should have. So the issue arises with the certificate authority key and the subject alternative names. Where are they? So, since it resolves as google.com and it has the same key identifier, it sees itself as a legitimate Google certificate. But Search Stealer actually is also currently running a man-in-the-middle attack against google.com. Accounts.google.com is an arrogate to all of Google. So if you actually man-in-the-middle this, it will actually resolve all of Google sites. And it just resolved. And if you see here, it says it got a connection from accounts and it went to so-and-so Google. And it logs each one. So through, if you want to use Hadoop, because it creates a lot, each individual session creates a log file. So if you want to use like Hadoop to find out the data analytics of what is happening in your man-in-the-middle, this would be the ideal setting for that. It is also acting as a phishing hole. Because this Google is fake. This Google actually has an embedded malware, beef script. So when you go to Google, it says it's fine, but it actually has beef hook in it and your browser is now hooked. So it's no longer a good Google. Do I have? About 20? Okay. Well, that's okay. And if you want to use Search Stealer, that is the GitHub, and that is the QR code to go download Mantra. I'm ready for Q&A. Sure.
I heard Wireshark has some upload vulnerabilities in it.
It definitely does.
Definitely does. And I was wondering what you recommend for getting around that. I mean, I've heard people say use TCP dump and then copy into the file and then read Wireshark.
I mean, in theory, that would work. That's an extensive work. If you're per PCAP, depending what you're running, that could be hours of work to do that. In theory, with EtherCap, if you wanted to run it in a secure sense, you would probably want to have like a TCP wrap over on top of it, run it through a tunnel inside that, and that would probably avoid some fingerprinting detection of the service. If you also switching the ports around probably would help also that it talks through, because then it wouldn't be fingerprinted properly when somebody tries to map your server.
So I didn't totally follow all the layers of your stack. So Mantra itself is an ISO
Yeah,
of some Linux distro.
it's actually based off Ubuntu.
Okay, so it's an Ubuntu-based distro, and inside of that you're running LXC or a number of LXCs?
Yeah, exactly. That
And where does KVM come in the picture?
KVM talks through libvirt to basically talk to genetic cluster to be the load balancer for the virtualization.
Okay. Alright. So, and I apologize. I totally follow your whole demo and exactly what happened there. So, you're running a web server.
Yes.
That was purporting itself to be Google.
Yeah, I actually had another VM set up, but I only have so much memory of a DNS server that I actually breached to make it Google.
Okay.
And then from there, I just pretty much created a fake server file of the google.com index file, put it into the server root, and then put a malware script in there.
Do you want to go through?
Sure.
Yeah, I didn't know exactly how you did the, essentially, it looked like you were spoofing the server, right?
Yeah.
And so, can you go into a little more detail on that? That was kind of interesting, but I didn't mention.
Absolutely. So Search Stealer is a automated script I wrote over the Christmas week because I was mainly bored and wanted to destroy certificates. So let's say Akami sites have a fast. So this is just pretty much taking it through. It just found this whitehouse.gov is an Akami site, so it has like a 30-second timeout, so it should take no time to actually. So what it's doing right now is copying the certificate that they're currently using. It captured the root CA, and right now it's copying those two each individually into a file. And pretty much now I'm creating the false certificate, so the false CA. So now I just created a key. Now I'm going to go through a P12 transform to embed the original stolen certificate with the key. Now it's actually just turned the P12 and now it's going to a PEM. And it just wrote out a certificate. So now if I restart my and now it's an Akami certificate. And this time it's just working because the pinning is similar to the last. But what it's doing is pretty much this part is the genuine certificate. This is actually the issued by is the false. It's a fake CA.
So, how come the browser thinks it's real? What did I miss there?
Oh, so this is part of the issue with subject alternative names and the CA issuer key, because those don't change because that's embedded on the first certificate. So it sees itself pinned so organically to the original that it's okay. But if you look, it says Chrome is still showing it as a broken SSL certificate, but it doesn't know why. That's the reason why it allows it to go through without the red screen of warning is because it just doesn't understand why the certificate is not working properly.
Have you emailed the Chromium folks about this?
Not yet. It's a to-do list thing. It's on my list of things to do. So.
You tried another browsers also, or is it just regular to web or WebKit?
It seems to be WebKit, but let's see. Oh, it must have not like him. Yeah, and Google saw that my client side was not proper and it kicked me off. So So, yeah, that's Chrome. Wrong browser. See, with their pinning engine, they actually still have figured out that the connection cannot be trusted. And it's possibly because they're not as dependent upon pinning, more of OCSP validation versus just looking at the certificate and CRL. So. And now they're making. And it's Google. So, any more questions?
So what other kinds of stuff do you do with the Metro OS?
Generalized attacks I can do from, I use Zap a lot as my preliminary diagnostics tool. You can do Wireshark attacks, you can do almost everything you can do on backtracks. But
So is there really no advantage to using this over Backtrack or Kali?
the advantage would be is the virtualization layers and the sandboxing and security. Backtrack is not designed for security of the tester or implementing into an infrastructure that needs security. So like if that would be the main difference is it by default is deployable into a vSphere setting and is considered as secure enough to be used for full-on testing in a enterprise setting, where Backtrack could be used by hackers for fun things to do.
Other questions?